Hello and welcome again to Fun with Interfaces episode 2 patterns. I sincerely apologize for all of you who have had to suffer through my fumbling again with my streaming equipment and setup for 20 minutes today. So this live session starts 20 minutes later than scheduled, and I'm very sorry for that. Thanks for bearing with me, for staying still with this stream, and I'm going to make up for your patience. As I have already announced in the previous original one, this time we're going to talk about patterns, and we are going to put them in context of interfaces. As many of you have requested on my blog in my poll where I asked what would you like to hear from me and what would you like me to cover in my live sessions, most of you said that you actually want to discuss AL patterns. So what I'm going to do is I'm going to present various patterns over the course of various topics. I'm going to put them into context of different things, such as today I'm going to put two very important patterns in context of interfaces. The first important pattern that I'm going to present today is called Dependency Injection, and it is one of the family of Inversion of Control patterns. And the second pattern that I'm going to present is the Factory pattern. As a matter of fact, I have already talked about Factory pattern in the first episode of Fun with Interfaces. However, I'm not going to go deeper into that pattern. I'm simply going to put it into a better context, or maybe simpler context to follow. And also I'm going to propose an improvement over that pattern that makes sense for the AL language and AL language specifics. And I call that pattern proposal a discovery factory pattern. So that said, let's actually jump into demo. And now I'm just going to confirm that my microphone does work. So if my microphone doesn't work, AJ, please call me again. So if I see a call from AJ, I will know that this is actually some problem with the session. And thanks, AJ, for calling the first time. If you didn't call, I would have continued and I would have delivered the entire live stream without sound. Anyway, so what do we have here? I have a very simple application, which is currency exchange functionality. So this is something that any Business Central developer can put themselves into. So this is something very easy to imagine. I will just have to ask you to imagine that there is no existing functionality. So the point here is not to expand on existing exchange rate or develop on top of it or anything. It is just to explain why you would want to use interfaces and when you would want to use interfaces and how you would want to use them. And then again, introduce several patterns while I'm doing so. So let's take a look at what I have here. I'll start with this page, which is currency exchange convert amount page, which has 4 fields. It has from currency code, to currency code, from amount, and to amount. To amount is non-editable, and other 3 you can select. So when you select what you want to, actually let me just run that and show that to you. So my app is now being published. I'm going to sign into my Docker instance. And then I'm going to try to convert €1 from euro to, HRK or Croatian kuna, which is my local currency. And yes, I get this 547. Before I go into these numbers and what happened here, let me take another look at my code. So how do I translate that? Well, I have this exchange rate management code unit, and this is a typical, I wouldn't call it a pattern, it's just a concept that is so deep integrated into Business Central logic to have those management code units. Standard application has total of 162 management code units, which are in fact handling various things from price calculation to web services to JSON to whatnot. So I have this exchange rate management code unit, which has this method called convert. And when I call this method convert, I'm actually starting my business process. And the specifics of these business process are what matters for this presentation. So my particular process has 3 stages. The first stage is it has to check the permission. is this user even allowed to perform this exchange? Let me show you what I mean by that. I can try to convert from US dollar to Croatian kuna, but then it says that currency exchange rate is not allowed for Vjeco from US dollar to Croatian kuna. Why is it not allowed? So a part of my application is this security area, where I have a permission table and permission page and permission management code unit. This code unit has this single method called canConvert, which checks if a specific user is configured to be able to convert from a currency into another currency. So let's take a look at currency exchange permissions, and here I can see that yes, Vjeco is allowed to convert from euro to anything, but not allowed to convert from US dollar to anything, which is why Vjeco can do that translation. So that's the first part of my process. The second part of my process is actual conversion. So for this actual conversion, I'm using the exchange rate table, which is a standard base app Business Central table, which already has some functionality to convert from currency to currency. And then last step of my business process is to log the results of this exchange. So I can actually check my conversion log, so currency conversion log, not long but log, and I can see currency exchange log. And I can see that I have 3 conversions. Yes, 2 come from previous session where I have fumbled with my microphone. So these are the components of my app. And then let's actually take a look at some of those, what is happening here. So check permission is a function inside of my exchange rate management code unit, where I'm invoking my permission management code unit and check if I can convert. And then log is a function which simply calls my log currency exchange log code unit, which simply writes that into log. Now that we have seen that, what I wanted to focus on is the fact that the exchange that happened, and let me just go back into my live instance, sign in again, and then show this result. So here I'm again converting, let's say, €2 from Croatian kuna again. And the problem is that this exchange rate here is far from correct. So apparently data inside Business Central is wrong for whatever reason. Maybe it wasn't updated in a while, maybe wrong source was used, maybe some user maliciously fumbled with them or changed them so that I cannot get correct calculations. So I want to actually not use Business Central exchange rate table. I actually want to use a live, trustworthy web service for that. So what I have here is demo2 branch. And just for you who have joined my second attempt at streaming, all of my demos are available on my GitHub. This time it is actually, it should be a public repository. Yes, it is a public repository. So it's github.com/vjecob/FWI2 as fun with interfaces 2. And here you can choose a branch that I'm currently working with. You can follow all of my demos. So I'm going into demo 2, and here what I have done is I have added another function. So I have a function called convert by setup and convert by rest. And it kind of hurts me to say that this is a typical approach of those management code units, that if you can do something in several different ways, you would have several different functions to achieve that goal. So when I go to my convert amount page, I have convert by rest this time, and there is very tight coupling between both my page and my code unit, and then my code unit and specific implementation. So I have my convert by setup, which is using Business Central setup, and I have convert by rest, which is using REST API. Please ignore the fact that the URL is hard-coded. It is not a topic of this session. So now that I'm using currency exchange rate from a REST web service, I can try again to convert from euro to Croatian kuna, and I can see that the exchange rate is different. So this is far closer to the truth, and this is now fine. So what I have achieved is that I have two different behaviors which are achieved using two different functions. And then if I need one function, I can call one function. If I need another function, I can call another function. But this is just not the cleanest design. So this kind of design, and this is design really double quoted, you really have a very tight dependency here. I do not want my page to actually have this hard-coded, nor I want the user to select in the page, like convert using this, convert using that. There should be some system decision on which one to use. So at this stage, I would like to introduce interfaces or reintroduce interfaces. I have demo 3 branch, which actually structures this a little bit different. So I'm still using my my exchange rate management code unit, which now has only one function. And I call that function directly from my page. But what I have introduced is my converters, and here I have iConverter interface. And this interface represents any currency exchange rate converter. No matter how it achieves its conversion, it can convert, and that's all I need to know. And all of my exchange rate converters receive a source amount or from amount. They receive from currency code, they receive to currency code, and they return something. And then I have two implementation code units, the BC currency converter, which uses the BC setup, and the second one is REST, a REST converter, which uses the REST web service. So when I take a look at my exchange rate management code unit, at this stage, it simply receives amount from currency code to currency code. And yes, this branch will not really run. To properly run this branch, you will actually need some decision. So you will have to write some code in there to make decision which converter to use. But what I want to use is I simply want to use this interface. I don't want to use an explicit implementation of a specific exchange rate converter. So I have decoupled twice. So I have decoupled a specific implementation from the page. The page doesn't need to know anything about the implementation of conversion. So it will simply call this exchange rate management convert method, which will then make necessary decisions. And I have also decoupled it here. So here I do not care about implementation either. So I simply call my converter and I convert. No matter how it is, it can be Business Central, it can be REST, it can be whatever else. So it can be some funky web service which places a phone call and then uses language recognition to, I don't know, anything at all. So the point is that this method doesn't care, and it shouldn't care. So at this stage, let's actually talk a little bit about the problem of tight dependency coupling. So in tight dependency coupling, which is something that we see all over the place when we are writing or reading Business Central standard code, we have this situation where we have a consumer, and this consumer uses a dependency. And this consumer directly uses that dependency. The problem with that approach in general, and this is still abstract approach, is that the consumer needs to know not only about a dependency, it often also needs to know about specifics of that dependency. So for example, what we were able to see earlier was that I had a currency exchange rate code unit, which then consumes a web service. So this currency exchange rate method needs to know about specifics of the implementation of a specific exchange rate converter. So this is tight dependency coupling, and this is something we can improve upon. And this is where I would like to introduce inversion of control. So it sounds probably scary, like what does it mean, inversion of control? And when you take a look at what it really is, it's just a very simple inversion of this picture. So instead of my dependency, my consumer using dependency, I have my consumer obtains dependency. So my consumer simply needs to somehow come across a dependency, and then it needs to use it. But it doesn't need to know about dependency itself. So this dependency now enters the consumer from somewhere, and we will talk about that. And then consumer can use it regardless of what this dependency is. It can be, again, Business Central setup, or it can be a REST web service, or anything else for that matter. So this is just in general what inversion of control is. And I wanted to put that into this into the context of this demo now, I want to actually show how we can apply this inversion of control inside Business Central code. So let's take a look at the next branch, which is demo 4. So inside my demo 4, what I'm doing is I'm doing something I talked about last time when I talked about interfaces in the first Fun with Interfaces episode, where I have bound interfaces to an enum. And I'm now trying to see. Okay. So the first step, what I did is that something is wrong here, or not, or maybe I just jumped a little bit ahead of my time. So what I have defined here is the currency converter. Sorry, yes, this is what I was looking for, setup group. So setup group is a new thing inside of this demo. So I want to start here. I have introduced something that is again typical for Business Central, which is a setup table, a configuration table for a business area. In this case, it's currency conversion. So my table has one relevant field, which is converter type or currency converter, and this is an enum, which is currency converter type. And this currency converter type implements demo iConverter interface. So we have already seen that interface a minute ago. So that's an interface which simply has one single method. And then I have this enum, which can be value Business Central, which implements this, which is implemented through this code unit. We have seen it a minute ago. And then the second is REST, which implements, is implemented through this REST code unit, which places a call to the web service. So this is my my setup. So when I now go into my application and configure it, I will first close this, and I'm going to currency setup, and I will show that now, yes, I have BC converter configured as my currency exchange converter of choice. And then let's take a look at this exchange rate management. So here I have this method called getConverter. And my convert method doesn't really care how this getConverter handles it. So what it knows is that this getConverter will obtain a reference. And then again, I would like to refer to this screen. So I have obtained the reference of the converter that I want to use. And how have I obtained it? I have simply used this setup table. So the reason why this works is something I explained in my previous video, but again, just a refresher, currency converter is of type enum. Enum is directly castable to value to variables of matching interface. The only compiler prerequisite is that this enum implements this interface. So I can validate or verify that it does. And if I go to this enum, I can see that yes, it implements this. So back in here, I can see that I'm simply retrieving my setup record, and then I'm retrieving or obtaining my interface reference from there. And then my convert method simply uses that. So I have inverted the control of this dependency. So this dependency is not anymore tightly bound to my convert function. So whatever way convert obtains this dependency, it will consume that dependency. So if I take a look now what is happening inside of my convert amount page, I can try to convert from €1 to 1 Croatian kuna, and it's 547. That's simply because here I have BC converter. But if I switch to REST converter and then do convert amount, and then try to convert from €1 to 1 Croatian kuna, it's 755 because it's using a different one. So this is now inversion of control at work. However, what you might not notice here, it may seem that this is, wow, this is amazing because yes, we are using enums the way how they are supposed to be used. But this is actually not the best way, or actually we can do even better than this. So yes, enums absolutely simplify this thing, but still, if you look at this code over here, you can see that I still have some dependency. So what I've done is I have replaced one dependency here, this one, with another one. So in earlier version, I had tight binding between my method to a specific dependency. Here I'm binding it to a setup dependency. So what I've done is I've pushed the first dependency below, like under the carpet, and then I've just put another dependency in its place. So this is not good enough. My convert method is really not in the best shape it can possibly be. So at this stage, what I would actually like to talk about is dependency injection. So let's take a look at this screen. So it's, again, inversion of control pattern. It only works a little bit different than this very basic example that I've shown of plain inversion of control. Dependency injection has a very simple principle that a caller who calls some method or depends on some object should pass dependencies into that method or that object. So we have seen that my exchange rate management consumes some kind of dependency, which is a code unit which can convert between between currencies. So instead of consumer obtaining that dependency, it's the caller's responsibility to inject dependency into the consumer. So if I take a look at my demo 5, and I'm now switching to demo 5 branch, please pay attention to the signature of my convert method. So I'm going to use that. And what happened here is that this convert, which used to be a variable, I'm going to switch between these branches. I had converter as variable. Converter has now been turned into a parameter. So it's caller's responsibility to pass this interface into it. So my convert depends on specific converter. So instead of it having to worry about it at all, it's the caller's responsibility to provide that dependency to it so that it can properly consume it. It might not be absolutely clear today why this is a beautiful pattern, but next week when I talk about testability, you will see, and this will just fall into place nicely. But for now, just bear with me for a little. Let's take a look at this and why this is an improvement over the previous iteration. I'm going back to my page. So here, my page is calling my exchange rate and it's doing conversion. So this is, let's call it user interface level of behavior. So when I'm inside of Business Central user interface, which is here in this page, then it's probably obvious that I should use the setup table. But let's imagine that you're calling this using an API call. And then maybe you do not want to depend on setup. Maybe you want to specify which specific converter you should use. So in that case, this setup might not be relevant. So it's the responsibility of the caller, in this case my page, to specify which specific dependency should this method use. So my convert dependency is using setup.currencyConverter. So I'm retrieving setup here instead of in here. And then I'm passing that dependency into my convert. So my convert now receives a dependency and consumes dependency. So when you take a look at this code, there is absolutely no dependency at all, no binding at all of any kind between this management code unit and any of possible implementations. This is just a very clean code unit which is concerned with just one single business process, which is validate if I am allowed to convert, second, do conversion, and third, log the fact that conversion has occurred. And it is not concerned with anything else at all. So, and this is why this is more beautiful. Even though, yes, you could say, yeah, but I need to pass an extra parameter. It will not hurt that much. It will be far better than the previous state because we are going to build more on top of that. And especially, as I said, and this is a teaser for next week, in testability, this really is a very beautiful pattern which you cannot really properly live without. However, this is not, I apologize, my winter asthma is bothering me, so this is not corona. Let's take a look at a couple more things. Here, I actually had one dependency which was obvious. This was my currency exchange rate. But I have two more dependencies here. So I have this permission dependency and I have log dependency. What if I do not want to check permissions against my permission table? What if I want to, I don't know, go into Azure Key Vault and check if somebody should be able to convert, or maybe call a web service somewhere else to check if somebody is able to do. Like, this is a dependency as well. And so is this log. So here I'm logging into a table. Maybe I want to log into event log. Maybe I want to log into a file. Maybe I want to log into web service. So all of these are actually very hard dependencies. So my exchange rate management code unit, yes, it's concerned with converting using some specific converter, but it's also tightly bound to checking permissions using a table and writing log into a table. So it has to know about these two hard dependencies directly. So let's improve on that. Let's actually inject a couple of more dependencies. I'm now switching to demo 6. I'm not running this one. The result will be exactly the same. You can try it yourself if you want. So my branch 06 is actually very simple. So my demo exchange rate management now receives 3 dependencies. It receives converter, permission checker, and logger. So these are 3 interfaces, and it's concerned only with its own business process. So the only thing that my code unit is concerned with is converting, or actually performing my process, which consists of 3 steps. First step, check if I'm allowed to do that. Second step, run the conversion. And third step, log the conversion. And I don't care how the permissions will be checked. I don't care how it will be converted, nor I care how it will be logged. But my process will complete, regardless of who are specific actors who are performing these tasks. And this also means I have a couple of more things inside my security. I have permission checker interface, which now has this can convert, and I have moved my permission checker from permission management code unit into BC permission checker, which implements it, and to REST permission checker, which implements it. And I've done the same with logging. I have iLogger, which has log method, and I have 2 loggers. One is BC logger and one is REST logger. So these are the changes that I've introduced. Also, I have introduced some minor changes in my setup table. I have 2 more fields. I have not only converter field, I have logger field, and I have permission checker field. And when I run this, I can actually configure which ones I want to use. So I'm going to cancel here and cancel here. I'm going to currency exchange setup table directly, not table, page. And I can see that I have 3 different ones. So I want to log into REST, and I want to use REST permission checker rather than Business Central. There are no implementations in here. Apparently there is REST logger does nothing, and so does my permission checker. It also does nothing, but it's here just to show you that there can be multiple implementations. And then I can actually extend my page to set up, get just this entire setup record, and then pass 3 different interfaces, which is converter interface, permission checker interface, and logger interface. I'm passing these 3 into my convert method, which now receives 3 dependencies. So I have injected 3 dependencies into it, and it is able to perform its task. And I can actually validate that it's performing it correctly. I can go into first, I'm going to open this table, and I'm going to start with the REST converter, and I'm going to use my convert amount page to convert from €1 to 1 HRK. And then if I switch this from BC, it will be exactly the same. Actually, not the process will be the same. It will be the same result as we've seen before, which is HRK, which is 547. So we can see that my currency exchange code unit performs its task without ever worrying who is checking permissions or who is logging, but it still completes everything it needs to complete. So At this stage, I have covered everything I wanted to cover about dependency injection and inversion of control. And what I would like to do is I would like to switch into a different pattern. So all of this looks nice. My page calls this exchange rate management code unit, which is, let's call it a module, which performs a specific task. I have injected dependencies into that module so that the module doesn't need to care how it performs a task. It has the tools to perform the task. It uses those tools and it performs the task using the tools that the caller provides. However, I still have this tight binding here. And yes, while this is something that is very common to Business Central, I'm not entirely happy with that. So I want to go and fall back into the factory pattern. So I'll close this page and I'm going to actually open this branch 07. So let's observe this AL pattern template folder when I'm discussing the factory pattern. So why is it called factory? Because it produces a handler for specific functionality. And this handler is, I'm going to call it a product. Typically, product, in my case, earlier case, it was currency conversion, it was logger, it was permission checker. So these were different products that I want to be produced using a factory. So this product is typically an interface, which can be implemented by several implementations. So I have this product, which is implemented 3 times by 3 different code units. So that's where all factory patterns start. You need to have an interface and you need to have several implementations. So what is factory about? Factory is about creating a specific or obtaining a specific instance that implements a specific interface without the caller having to worry about which specific implementation will be used. So I have create product method. It receives by reference iProduct interface, and it returns Boolean to indicate whether or not the factory was successful at creating that interface. And then this is not something that is a part of the pattern. It is just here to show you typical decision path of a typical factory pattern. And this is that you will have some kind of a switch which makes some decision, and then based on this switch or case, in case of AL language, it assigns a different implementation to this by reference parameter. And then if it cannot find an implementation, it exits with false, indicating to the caller, sorry, I couldn't find any implementation, or true, which indicates to the caller, yes, I have successfully obtained an interface for you, or an implementation of that interface. Here it is, please use it. So this is a typical pattern, so you can really use this as a snippet. This is boilerplate for all factory patterns. And then consumer typically looks like this. You use the factory and you use the product as interface, and you call factory.createProduct, and then the factory is in charge of giving you a specific product implementation, and then you use that product directly on the interface without having to worry about which specific implementation of the use method it is. You just use it because this is the interface that you know. Alternatively, if you care about checking if the factory succeeded, so you will do if factory create product, then product use, else whatever. So this is typical usage of a factory pattern. And then what we can now do with enums in AL is that we can actually bind this to enums. So enums are actually an implicit or a built-in factory. So simply by declaring this enum that implements your product and then binding a specific implementation to specific value of that enum, you get rid of this option and you get rid of the case. That's something which is now implicit in your enum. So your factory pattern with enums would look like this. The first step would be to retrieve the product type from somewhere, maybe from a setup table or maybe from somewhere else. And then you exit with false if this doesn't succeed. Step 2 is to assign from that enum that you have obtained. And step 3 is to exit with true to indicate success. So this is something that we can do with enums. And this is something that I have now implemented in this example. So I'm going into my source folder. And I'm going to close these converters and logging and security. There are no changes there. where I have change is my Dependency Factory code unit. So this is a new code unit which has 3 create methods: create converter, create permission checker, and create logger. And then all of them receive by reference a specific interface, either it's a converter or permission checker or logger interface. They all indicate with Boolean whether or not they succeeded, and then they perform the assignment. So first step is they obtain this from somewhere. So my factory obtains it from setup. Then my factory assigns it, and then my factory indicates with true. So my exchange rate management code unit now looks like, page now looks like this. Instead of depending directly on the setup table or setup page or anything at all, I simply depend on the factory. So I have my dependency factory, and I don't care how the factory will obtain my references for me. I know that it will. So what I do, well, I didn't use the if create then, just for simplicity, so it's easier to follow the code. I obtain a reference to converter, I obtain a reference to permission checker, I obtain a reference to logger, and then I inject them into the convert method. So this is now factory pattern at work, and this is an improvement over the previous one. Again, this will have the biggest benefit, transparency, when we are going to talk about testability. But it's also very nice because of just general decoupling of my page from any specific setup. So now this page can be used with whatever setup or whatever situation, and I'm actually deferring the decision of which interface to use to this factory. So when I run that, no wonder it will still perform exactly the same conversion. So if I do from euro to HRK, it will perform the BC conversion because that's how it has been configured. So good. And what I want to introduce is a different pattern, because this is a very nice pattern with enums. And if you take a look at my factory, this factory is using an enum, and this enum is actually extensible enum. It has no, let's say, undefined values. It has default value of BC. It has value of 1 of rest. So it means it will always have some kind of implementation, provided that users don't try to kind of use incorrect values like 52, for example. So this might seem complete, like you have covered all possible situations. If any other developer wants to create an application which depends on your application and cares to extend this enum, and you should allow extensibility of these kinds of enums, which are factory enums, simply by providing an implementation and creating a new enum value, the factory would still work, because this enum would contain this new value or new implementation. But still, what I prefer with factory pattern is an improvement, an event-driven improvement on top of that, which is something very AL or typical of AL, is my demo 8, where I have a very different pattern. Before I go into this, I'm just going to show this template again. I have my discovery factory. So the difference is this, that the first step is I try to discover my my interface. So I'm doing this discovery where I'm saying that I want to find a pattern using an event, and then anybody can subscribe to this event and can actually fill in the interface that I should use for this specific situation. And then if this was handled, then I exit, which means the product is actually assigned. So I exit with true. If this is not the case, so if nobody cared to respond to onDiscover, then I perform the typical factory enum factory process, which is I retrieve it from somewhere, from setup, for example, I assign, and I return. And then let's take a look at my dependency factory now. So what I have here is I have my factory methods, I have my factory events, and I can subscribe to those events, and then I have the same exact same exchange rate management, and then again exact same convert amount page. So there is no functional difference, but inside the factory, it is more powerful because not only I'm retrieving the interface from a setup, I'm actually creating an event that anybody can subscribe to and provide an implementation for any specific situation. So with this, I'm actually going to stop showing any demos. I'm going to stop discussing any code, and I'm actually going to switch back to my live stream, and I'm going to answer any questions that you may have or address any concerns. So thanks. You all said that you can hear me, that it works, and then Waldo said, come on guys, click that like button. So yes, absolutely, Waldo is always right. Just click that button. Also click that subscribe button that you can find over here. And when you click that subscribe button, also click the bell icon to actually receive the notifications. So tell me, what do you think about these patterns that I've presented today and about these concepts? I'm eager to hear. Or I'm also eager to answer any questions. Either I confused you or I explained everything so you just understand absolutely everything and you don't care about asking anything. Or is it just me, and my total incapacity of being able to foster discussion? So Waldo, am I right that this pattern is if very alike the facade pattern you might remember? Yes, I do remember facade pattern. It is similar. You could say that both fall into what Gang of Four group of pattern definers, those guys that defined most common or most typical patterns back in the 80s, would call creational patterns. So that's what factory pattern is. Dependency injection or inversion of control are not. So I wouldn't call the facade a inversion of control. It's similar but not the same. So thanks AJ for the comment. I'm glad you liked it. So again, you have all the demos available on my GitHub. I'm going to show the page, and I'm just going to, I cannot zoom into the URL, but it's, I can just show this part. So this is where you need to go. Any other questions? Is there a way to mark an interface as internal, like you can do for procedures and objects plus extensible property for enums? I actually think yes. This is a question I don't know the answer by heart. Let me try. I think that this is absolutely, no, it's not possible. So no, you cannot do that. But I would say that no, you do not want to do that. So the reason why you would want to have interfaces is because it allows you to have this flexibility. And there are very few situations when you would actually want to have an internal interface. So let's think of my currency exchange rate. And then I have my app which provides this exchange rate functionality. And then somebody sees it, oh, this is nice, but I want to provide a different exchange rate converter and different permission checker, for example. So they develop a app which depends on my app, and they want to extend my interfaces, or actually not extend, but implement my interfaces. That's the only thing they need to do. They would need to provide a specific interface for my converter. They would have to provide a specific interface for my logger, this one, and they would have to provide a specific interface for permission checker. If they care, they would also have to extend those enums that they care to extend. But I would actually say that you typically do not want to mark interfaces as internal. You typically do want to have them as external or public or whatever you want to call them, just available to anybody who is consuming that. And again, you want to make your app testable, and next week we will talk about testability. So you want to have your test app have full access to your interfaces so that you can test your application. No new questions in the meanwhile. So can we then obsolete interfaces so we can recommend new versions of them in case a signature needs to change? Well, this is again a question I cannot answer. I do not know that you can. I think you cannot mark a interface as obsolete? No. So you cannot mark it as obsolete, unfortunately. But yeah, I mean, it's a valid question. Typically, you wouldn't be doing that, but in Business Central world, where extensions are where they have a life of its own and you can depend on whatever, it might have sense. However, let me again just provide some off top of my head opinion. I think that you don't want to do that either. So if you want to obsolete an interface, you would simply just delete that interface and then you would just publish a new version of your app which doesn't include it. This is a breaking change, so whoever depends on your app, they will not be able to depend on the new version of your app until they actually remove that interface implementation and provide an alternative. So it's not like fields in the table. There is nothing that lives somewhere physically so that you need to properly care about during upgrades or whatever. You can just delete an interface and yeah. So yes, you're welcome, Bjarki, for your questions as well. So anything else? If not, this might be the first time I managed to finish in under 1 hour. So if you do not have any other questions, I'm just going to close this session. Thank you very much for staying with me today in my second episode of Fun with Interfaces. Next Friday, as I have announced, I'm going to have a third episode of... Okay. Before I close, there is AJ's question. What about injecting the setup into the factory? That is also a possibility. So if in fact what you could easily do is this, your factory, and let's talk about concrete factory, could easily have a procedure initialize. And let's say it's some interface called iSetup, which can then be a code unit which implements a table or retrieves it from somewhere, and then you use that interface instead of this table. Yes, absolutely, it's possible. It would be nothing else but just dependency injection. So it's there is nothing that tells you should not inject things. And I would say whatever makes sense for you to inject somewhere, wherever you have any hard dependency that proves to be an obstacle, you should actually inject it from the outside. And this is crucial. Proves to be an obstacle. And while today maybe none of this seemed as a direct obstacle, next week when I talk about testability, you will see that any kind of tight binding is an obstacle to testability. And you actually want to have far more dependency injection all over the place. And then maybe the picture will be far more clear. So yes, you can do that, and it would be actually a very good idea to do that. Yes, I think this is now, yeah, Waldo, good job again. Thank you. You're welcome. You always keep me motivated. Ladies and gentlemen, thank you again for staying with me in another live stream, in another episode of Fun with Interfaces. Again, click the button on the left side, right side of your screens, subscribe button, and then click the bell icon to receive notifications when there are any news in my channel. And see you next week in the next session.